In the previous video, we went through and calculated in SPSS variance estimates in a couple different ways. Now we're going to take those variance estimates and play around with those in Excel to match up some of the examples from our textbook. So in Excel, again, all I have here is the raw data from our textbook. That was explained in the previous video. We just took that from table 8.1. We took this data, ran it through SPSS, and got variance components. Go ahead and click on our variance components. Here's the table we acquired. I just copied and pasted this from SPSS into Excel. We can see that our mean squares for persons is 10.3 and our raters 4.9, and we have an error mean square of 1.044. We also have our estimates here of 3.089. Our first estimate for variance is for persons. Our second one is for the variance of raters is 0.389, and the third one is 1.04. We went over those in the last lecture video for SPSS. Let me just give you a short reminder that in our examples in our textbook on page 160, we have 4 examples, 4 different D studies that we're doing. We went through, and the data that we just collected is from a G study. So we've gone through, we did a preliminary pilot. Remember, G studies always in the past. We have existing data. We calculate the variance components for this. Now we're going to see what would happen under different scenarios, and that's in the future, and that's what we're doing in our D study. So our examples in our text, the first example we're going to do right now is that each examinee is rated by one rater, and this rater rates all examinees. So we have an equation in our textbook on page 165, which goes through and helps us calculate out using variance components. Also does it with mean squares to calculate out what the reliability in this case would be. And we can see that I have from page 165 equation 8.6. I've gone ahead and just plugged in those values. You can see here as I highlight it, I take the variance of persons, B14, that value of 3.08889, and divide it by both the variance of persons, and I add in the variance component of error. Rater is not included. We talked a little bit about this in class with relative versus absolute measures, and everything entangled, in this case for the generalizability coefficient, everything that is for a relative coefficient, everything that entangles person we will include in the denominator, and we'll see later on where we can use an absolute measure or an absolute coefficient to entangle all of our error variance. So that's example 1. Let me escape on that. And in that example, that would be what would happen, what we would expect in the future if our raters were randomly selected from the population, and in this case we have for each examinee is just one rater. So let's go on. Another example they give, I'll just kind of go over this one very briefly. In the textbook they talk about what happens if you just want to know something about the reliability of one individual rater, a very specific person. You have information. So these are on page 166, equation 8.8. We can see in that equation for the numerator and denominator, we take in the numerator, I'll go ahead and run through that first portion where we had the variance of 1, the variance of the standard deviation of 1, standard deviation of 2, times that rho 1, 2. Well, that's just the rater 1 standard deviation and rater 2 standard deviation and how well they correlate together. In this case, we're taking 2.57 and 1.26, and we are multiplying that by 9.5. You should see that in the textbook as well on page 166. And that second component in the numerator, we are taking how the variance of person 1, and the standard deviation of person 1, 2.57, and the standard deviation of person 2, 2.04, and how they correlate, 0.79. You can also see that in the text. I'm taking those two pieces, adding them together, and squaring them, and I get the numerator of that component on page 166. And in the denominator, we are taking, using the denominator of that equation, which is 4 times, and we can see it's 4 times the variance of, in this case, E3. And E3 I have set up so that it's the variance of radar 1, because that's kind of what we care about. We also have the standard deviations of person, let me see, person 2 and person 3. And finally, we have in there the correlation between persons 2 and persons 3 in that denominator. Well, that's just to walk you through. We take those two and we take the numerator divided by the denominator, and we get the same value we got in our textbook. All this is, we get a relatively high value here because we know a lot of things about this person individually. It's not a random person, it's a specific person. And you can only do this when you know for some reason you are going to need this individual rater. But most of the times we don't have this situation.